So hey guys, today what we'll be doing is something called classifiers, and it's a machine learning algorithm, SVM classifiers, and another one. So we'll be seeing that when we start coding it. So what is a classifier? So you see, I have a data set over here. It has the total health, the HP, the attack, defense, and special attack, special defense, and speed. This is a Pokemon data set. You see, Bulbasaur has so much stats. So what we'll be doing is we'll be taking all this as input, and we'll be determining that if it's a legendary Pokemon or if it's like a normal Pokemon. So you see, this data set has around 800 values, and it has name, number, uh, name, type, number, generation, and legendary. But the type of Pokemon doesn't matter. It only depends on its health, HP, attack, speed, and these four columns. And even generation doesn't matter. And this legendary, we have to predict if it's legendary or not. So let's just get started, and we'll be using scikit-learn module for calling the functions and training the classifiers. So let's just get started. First, we have to import the data set. So first we'll import the modules. Then we need pandas. Then we will import the data set equals to panda.read csv, and it is called Pokemon.csv. That was its name. And the x, what we'll be taking as x is, one second. First we'll run this. And we'll save it. We have to save this Python file wherever the program is saved. So wherever the CSV is saved, so we'll save it here, and we'll call it 1. And when we run it, you can see it has 13 columns, and we need only column number. This is column 0, 1, 2, 3. So we need from 4th till 4, 5, 6, 7, 8, 9, 10, 11. We need it till 10. So we'll be using the ilog function to do so. So the x is data set dot ilog, and we want all the rows, so we'll put comma, and we want column from column 4 till second last column, so we'll put -2, and second last column is not included. So second last and last, -1 and -2 are not included, and we'll get the values. So dot values, and we'll use the same function to get the y, which is the output, and the output column is just the last one, which is -1. Cool, just -1. Now we'll be splitting the data set into test set and train set. So for that we'll use scikit-learn module. So from sklearn dot model underscore selection import train underscore test split. We call this function, and our x underscore train comma x underscore test comma y underscore train comma y underscore test is equals to this function, and x and y. Okay, and the test size should be 1/4 of the data set. So we have 800 columns, so 1/4 of it will be kept for testing it. So we put test underscore size equals to 0.25, 25%, and random state, which is basically how random should be the data selected from the data set. We'll keep it 0 for now. Cool. Just give me more space to look at it. And now what we have to do is call something called standard scaling. So if you see our x underscore test here, we'll have to run the program. If you see x underscore test, you see it has values from 270, 500. So what standard scaler does is it will convert all the values between minus 3 to minus 2 plus 3, minus 3 to plus 3. So it will find the average, and then it will convert all the values from minus 3 to plus 3 respectively. In this way, we won't have to deal with big numbers, and it will help with the effectiveness. What do you say? It will reduce the computing required to do so, to train. So for that we'll use a Sklearn module called preprocessing, and we'll import standard scaler. Yep, there is standard scaler. Yep, we'll import this class, and then we'll make a class variable sc, and this will make the scaler, and then training set, we'll first scale the training set sc dot fit transform. This function is called fit transform, and we'll be fitting x train, yeah, and we won't require fit parameters here right now, so we'll just remove it. And same way with the same scaler we'll have to do for the test set. Obviously we'll have to use the same scaler, we can't use another scaler, because then the average will be different, and then the prediction will be done wrong. So always use the same scaler for test set and train set. And so this is our data pre-processing is done. So now what we'll do is we just create the classifier and we will train it. So let's go into it. So first we'll use KNN classifier, and then we'll look at another one and see which one works better in our case. So first we'll call the module sklearn dot neighbors dot neighbors classifier, yes, and then we'll call the class variable, so classy so classifier is this, and it has different parameters. So our n neighbors, we'll keep it as 5, and then we'll vary it and see. The metric, we'll keep it at Minkowski, whatever it's called. Minkowski, and yeah, and we'll keep it at 2. We'll vary all this and we'll check it out. Okay, and that's all. Now the classifier is defined properly. Now we have to just train it. So we'll use fit classifier dot fit the values, which is x train and y train. So x underscore train comma y underscore train, done. Now the model is fitted with the values, and now if we run it, it will be trained. So that's KNN classifier. Now what we have to do is we'll have to put in the values, and after that check the accuracy and plot the confusion matrix. So for that we'll do from Sklearn dot matrices import confusion matrix and accuracy score. Cool. Now first we'll predict the values. So y predict is classifier, which was our classifier variable dot predict the x test, and now we check the accuracy. So for accuracy we'll be looking at for accuracy we have different things for accuracy, like r square or r mean, or we can just do accuracy score. So you just do the accuracy score easily. Classifier, so spelling mistake, and accuracy underscore score should be test, should be first. So y underscore test comma y underscore predict. That's all, and we have to print this obviously. So print. Now when we run this in neighbors, I think we have spelling mistake. Well, neigh neighbor, and now we run this. No cause matrices. Oh, there's an extra e. Just spelling mistakes. Yeah, so you can see the accuracy is 0.25% right now, and we can change the accuracy by changing the n neighbors views. So now the accuracy become a bit better. From it become 0.3. If we use more p's like 5, it has become 0.35, 93.5. So we can make it like 100 p's, and it still doesn't have any. So at 5 and neighbors at 7 gives somewhat good result. You can try 9 neighbors also. So 7 neighbors and P5 gives us the best result. So we'll have to tweak these values in our code later on to check to get the best results. So for us 93% is the best result and 93.5 is the best result, and these are the values for it. But visualizing this data will be very difficult for us since it has a lot of dimensions. So it is 1 2 3 4 5 6 7. It's 7-dimensional data. For analyzing 4-dimensional data is very hard itself. Like even PhD students, professors can't analyze 4-dimensional data, so we have like so many dimensions. So it's not, we can't do it as humans. Only computers can do it. So that's all, and that's all for KNN classifiers. Now we'll make another classifier called the SVM, the support vector machine, and we see what effects, what is the accuracy we get with that. So we'll call the module from sklearn.svm and in the same way we'll call the classifier. We'll store the class in the classifier underscore svm variable, and svc we'll keep the kernel as rbf, which is radial base function. It's kernel and this is rbf. You don't need to worry about that. These mathematics things are not required actually. We shouldn't go that much into it, and we'll keep the random state as 0. You can change that later and see what effects does it have, and then we'll fit it in a similar way. We'll fit the classifier with the data in a similar way, just that it's SVM. Cool. And yeah, so we'll have to predict the values also in the similar way. So we use SVM instead of classifier. We use classifier underscore SVM to see SVM score. From where is the mistake? What is this? Syntax. What syntax error is this? So we just remove this line and this line. Oh, there was a missing parenthesis. So we just put the parentheses here, and now it should be working. Yep. So now our accuracy is also 93.5, which is similar to what we had before. We change the random state and see what effects does it have. Doesn't have much effect. So we'll keep it as 0 only, and we can use like different functions here. Like we can use a ReLU function instead of radial base functions, and it will have different effect. But in this situation, the key neighbors and support vector machine are having almost similar accuracy. Yep. So we learned 2 classifiers today, and we can't visualize it, otherwise I would have helped you visualize it. But these are like multi-dimensional data. We can't even do 3D easily, so how will we analyze like 5-dimensional data or 6-dimensional data? So we have to just depend on the accuracy, and we have to try to increase it to a certain point, but we shouldn't overfit the models. So that's all. I'll leave the code in the descriptions for you guys to access it easily. And that's all. I'll see you guys in the next time, in the next video, and make sure you just subscribe to the channel. Fine. Bye.